So the purpose of our paper was to classify presence or absence of COVID-19 just given an So the purpose of our paper was to classify presence or absence of COVID-19 just given an audio recording of cough. So performing the classification this way compared to other testing methods is desirable because this technique is fast, scalable, and it can be done remotely. So the two main techniques that we explore are autoregressive predictive coding for pre-training, which we do with a large coughing dataset called COUGHVID, and then we fine-tune on the DiCOVA challenge dataset using additional layers and then the data augmentation technique called SpecAugment. So after performing well on the test set for the DiCOVA challenge, we ran some ablation studies, and we found that both the pre-training and the SpecAugment are critical to the improved performance. And so the big takeaways from our paper are that a large amount of unlabeled data can be used to help with a small amount of labeled data for this particular task of classifying presence or absence of COVID-19 from cough audio recordings. And then we also found in another experiment that speech data can be used. So if we pre-train with LibreSpeech, we still get improvement over the baselines. And then finally, we verified that autoregressive predictive coding and SpecAugment can be useful for this problem of classifying presence or absence of COVID-19 from a audio recording of cough. So those are the main points of the paper. Thank you for listening. I hope to see you at InterSpeech.
All right. Can you let me remind people that you can ask questions with the question mark button. There's a little question mark icon in the right-hand side of your screen. Let me ask you, can you say a bit more about how the APC works?
Yeah, and I apologize for not putting slides. I thought we were just supposed to talk, but I have a longer presentation and people can ask questions in the session after. But yeah, the autoregressive predictive coding is basically, it's very similar to BERT pre-training for NLP, where the goal is to take the past input and then just predict a future input at the output. So for our best working system, we used 10 future frames. So it's just the mean squared error between the output of the network and then the input 10 frames in the future. And so by having to learn this function, the system learns some, in an unsupervised way, some features that are useful for that particular input.
Thanks. There are actually a few questions in the chat. One is, have you seen whether cough is more predictable or less predictable compared to speech?
I'm not really sure what that means. We were just using we use speech for pre-training to see if we don't have any coughing data, if pre-training with speech, which is readily available, is still helpful. So you can check the results in the paper. The results for pre-training with speech are worse than with cough, but not by much. So I don't know if that answers the question.
Yeah, I guess the answer is, okay, let me ask a different question then. Did you apply, so another author says that they found COUGHVID to be very noisy and is asking if you applied any pre-processing to the data, for example, cough detection from the raw recordings.
No, we didn't do any, I don't think we did any noise removal. We just used the Mellog spectrogram features.
Okay, thanks. I think, so there's another question, why do you choose cough as an indicator? But I guess that's maybe one that we should pass to the organizers of the challenge.
Oh, yeah.
Let me instead go ahead and invite the next speaker to come and present. Thank you.
Thank you.